This video is dedicated to refractive index. So in this video we are going to understand refractive index in a better way, okay, and we are going to also look at the different terminology that is used in terms of with respect to refractive index. We've already looked at the different definitions for refractive index, and remember, refractive index is always that of the second medium with respect to the first medium. Remember that. So refractive index of the second medium with respect to the first is sine of angle of incidence in the first medium divided by sine of angle of refraction in the second medium. Likewise, refractive index of the second medium with respect to the first is velocity or speed of light in the first medium divided by speed of light in the second medium. So refractive index of second medium with respect to first is wavelength of light in the first medium divided by wavelength of light in the second medium. Let us now look at this terminology for refractive index, which is absolute refractive index. Now this absolute refractive index is also simply referred to as refractive index. Now wherever you see refractive index written in your book, okay, you need to understand it means absolute refractive index. Now what is this absolute refractive index? Absolute refractive index is the case when the first medium is always air or vacuum. We are considering air or vacuum to be the same here, okay. So when the first medium is always air or vacuum, then the refractive index of the second medium with respect to air or vacuum is called the absolute refractive index, of course that of the second medium. Okay, the second medium in itself could be anything. It could be glass, water, any kind of an oil it be, okay, any transparent medium, okay. But the first medium always has to be air or vacuum. So that is exactly what I've written over here. The refractive index of a medium with respect to air or vacuum is called the absolute refractive index of that medium, of course. Okay, so absolute refractive index of this medium is, say for example, is denoted by mu. So mu is speed of light in air divided by speed of light in that particular medium. Okay, this absolute refractive index of course can have other definitions also. Absolute refractive index will be wavelength of light in air divided by wavelength of light in that medium, or for that matter, absolute refractive index of this medium will be sine of angle of incidence in air divided by sine of angle of refraction in that particular medium. Now what if the first medium is not air? What if the first medium is something different? Like in this case, the first medium is water and the second medium is glass. Now of course, glass being denser than water, this refracted ray is bending towards the normal. So in this kind of a scenario, what would be the refractive index of glass with respect to water? Okay, so in this kind of a scenario we talk about relative refractive index. That is, the refractive index of a medium with respect to any other medium apart from air or vacuum is called relative refractive index. That is, the refractive index of glass with respect to water in this case is what is called relative refractive index. Now, let us consider this case. Say for example, the refractive index of glass with respect to air, that is the absolute refractive index of glass is mu g, okay, and likewise the absolute refractive index of water is mu w. Okay, so the refractive index of glass with respect to water is given by this refractive index of glass with respect to water. So this will be equal to the absolute refractive index of glass divided by the absolute refractive index of water. Okay, that is the refractive index of the second medium divided by the refractive index of the first medium is the refractive index of glass with respect to water. Let us also look at this example that is given in the book, a numerical. The refractive index of water is 4/3. This means the absolute refractive index of water is 4/3. Okay, and that of glass is 3/2. So the absolute refractive index of glass is 3/2. Okay, so what is the refractive index of glass with respect to water? So the question is asking you, what is the refractive index of glass with respect to water? This very case, the question is asking you what is the refractive index of glass with respect to water. It is asking you this. So here in your book mu WA gives the absolute refractive index of water, okay, which is 4/3. And mu GA is the refractive index of glass with respect to air. That is the absolute refractive index of glass, which is 3/2. So refractive index of glass with respect to water, refractive index of glass with respect to water is absolute refractive index of glass divided by absolute refractive index of water. The same thing that I showed you just now. So refractive index of glass with respect to water is refractive index of glass divided by refractive index of water. Same thing. Okay, so then after you only simply substitute the values. So this, as you can see, is absolute refractive index of glass divided by absolute refractive index of water, which is 3/2 divided by 4/3, and then after you solve it. This is how you do it, remember.